Yes, good afternoon, students. In the last class, we had discussed some basics about the sampling design and the prerequisites for sampling design. And in the flowchart, we had studied that how this process of sampling will be done. First, we'll be defining the population of interest on which we are interested in doing the research. Then we will determine the sampling frame. Then we'll determine the sampling procedure. The sampling procedures are broadly categorized into two types, that is probability sampling and the non-probability sampling. And under probability sampling, we have different methods like we have simple random sampling, systematic sampling, stratified sampling, cluster sampling. And under non-probability sampling, we have convenience sampling, judgment sampling, snowball, and quota sampling. So in the last class, we had discussed in brief about the different steps that are involved in good sampling design, starting from defining the population till getting the desired result. What all steps are followed in detail in sampling procedure we have discussed. Today we will explore more on what are the different methods of probability sampling and how these sampling are going to be used for the sampling design. That is, probability sampling is the method in which all the samples have equal chance of getting selected, or all the samples have, each and every sample has got equal chance of being included in the sample randomly. But unlike non-probability, that is in non-probability, there is no equal chance for the samples to be included in the sample. Okay, we will be taking, say for example, if we have okay, let us take an example that we have around 25 students or 25 population, and as far as the sampling is concerned, as far as the simple random sampling is concerned, or as far as the probability sampling is concerned, it is like a lucky draw. In lucky draw, what happens? We will take entire population, put it in the box, and we will give equal chance of being selected for each and every sample that is there in the population. Randomly we pick one, that like that every sample has got the equal chance of getting selected. So in simple random sampling, we have population members that are selected directly from the sampling frame. Suppose I have the population of 25 population, equal probability of selection for every member, sample size and population size is going to be divided. So suppose if I use some total number as 10,000, and suppose if the sampling frame is a sample size is 400, 0.04 is the, or 4% is the rate of selection of the samples. Use random number table or random number generator for generating the samples. Suppose there is no criteria like other methods in simple random sampling. Without any criteria, the researcher is going to select the sample randomly. Say for example, out of this 25, researcher selects sample 2, maybe sample 7, sample 8, sample 9. It is his own interest. All of them are having equal chance of being selected, but there is no criteria, there is no method, there is no formula for selection of any of the samples. That is the simple random sampling method. So that's what we had discussed in the last class, that N stands for the number of cases in the sampling frame. and small n is the number of cases in the sample, and n combination n is the number of combinations or subsets of n from n, and the sampling fraction is calculated as small n divided by the capital M. Okay, so selecting a sampling design, that is objective of the simple random sampling is to select n units out of n. So in this example, I have selected 4 units from 25. So that is it is going to give us the fraction, sampling fraction as 4 divided by 25. So that comes out to be 0.16 or something like that. So use a random numbers of a computer random generator to select the sample. So randomly the software will select the sample. So that was the basic and very primitive type of a sampling method, wherein randomly without any bias, without any base, the samples are going to be selected. So let us see the next method of sampling. Let us take again same number of samples or the same size of the population. The population size here is again 25. Capital N is 25, and this method is called as simple systematic sampling. That is randomly the things are going to take place, but it is not that simple as a simple random sampling. There is a systematic approach, that is, before you do that, order all units in the sampling frame based on some variable and number them from 1 to n. Then choose a random starting place from 1 to n, and then sample every k units after that number. So that is why we can see in the diagram that the third sample is selected always. This third person leave to third person, leave to third person. So randomly you are going to make, say for example, this 25 population, I can make a group of 5 samples in each group. So this becomes group 1, group 2, group 3, group 4 and group 5. So after selecting these groups, and in each group we have 5 samples. So which number you are selecting? Are you selecting the second number from each group? Yes, second from this group, or leave 1, 2, 3, 4, next fifth element. 1, 2, 3, 4, fifth element. 1, 2, 3, 4, select the fifth element. So like that every k units, after that you are going to select the sample. So here is another example of a population of 100. Here the number of units is numbered from 1 to 100. Decide on the n, that is the sample size that you want or need. That is k is equal to capital N by small n. That is the interval size. So I have taken small n as 20. Okay, and capital N is 100. 100 divided by 20 gives me 5. So randomly select an integer between 1 to k. That is, select a random number from 1 to 5, and then take every kth unit, start with 4th and take every 5th unit. So you are taking 1 to 5 as the sample interval size. Then in between 1 to 5 you have selected 4th member from that group, and between 6 to 10 again 4th member, between 11 to 15 again 4th member, between 16 to 20 4th member is 19. Like this, from a unit of 5 units sample, from a sample frame of 5 units, you are selecting 4th member from that small frame. So like that you have 100 samples. For 10 samples you will be selecting 2 members, 4th one and similarly 9th one. Similarly, like that, if you continue, you have 100 samples. 100 samples means roughly you will be selecting around 20 members from the entire population. That is 4, 9, 14, 19, 24, 29, 34, 39, like that. So that's what I had shown. You will be making a group of 20, and you will be making selection of this particular K unit. So this is the simple systematic random sampling. That is, systematic random sampling is going to select the every kth unit from the given population. Okay, this is the second probability sampling design method, that is selecting using systematic random sample. And the third type of probability sampling technique is the stratified sampling. Here we will be dividing the entire population into strata. Okay, strata means groups, and the number of groups can be decided as per our convenience. Say for example, I have 1 to 25 here, but whenever I make a stratum, all the members in that group are having common characteristics. That is very, very important. Identical members, identical samples are grouped together. There is some criteria behind making a stratum. So we have to order the strata, and we have to make the groups in proportional way. Say for example, we have 100 people. So 100 people means maybe 60 women, 40 men. Out of 60-40, when I make this stratum, that proportion has to be 6:4 or 3:2. Suppose if I make a group of if I take a group of 100 people, this 100 is divided into 60 women and 40 men. So that is, I will be maintaining 6:4 ratio or 3:2 ratio. So I will be making a group of how much? In the first group, I will be having 6 men, 4 women. And in the second group, again I will be having 6 men, 4 women. Like that, how many groups we can have? In one stratum, I have 10 members. Okay, I have 10 members. So in order to cover the 100 people, I will be having group 10. In group 10 also, I will be having 6 men and 6 women and 4 men. It's not possible that I will have 6 women in the first stratum and 1 man in the second stratum, and say in the second group I have 2 women and here I have around 19 men. No, it is not correct. There has to be a proportion between the number of women and the men, depending on the total number of these population in the entire group, and depending on the ratio of the stratum. Because say for example, if you want to divide the people like out of so many those who have some basic characters, say some students study history, some students study mathematics. So we have to take representatives for representing mathematics group. Those who have studied mathematics, only they have to be part of the mathematics group. We cannot take any student who is not studying mathematics, who is studying history, to represent that particular group. That is the basic criteria. No student of history should be involved in mathematics group or included in mathematics group, or no student studying mathematics will be included in the history group. So in order to make the stratum, in order to make the groups, we will be using common characteristics. If they fulfill that common characteristic, then only that student will be included in the particular stratum. So suppose if you take 25 students, so based on the proportion you are going to make a strata, and you are going to follow the steps. That is, in stratified sampling, the chosen sample is forced to contain units from each of the segments or strata of the population, equalizing important variables. That is, year in school, from same geographical area, and those who use that product, those who are using that particular product, those who have purchased that product, only those members will be based on some variable and based on some criteria, the groups are made. Okay, what are the steps involved in making stratified sampling? The first step is population is divided into mutually exclusive and exhaustive strata based on an appropriate population characteristics. Okay, based on some gender, age. Just now I had taken an example of gender. I had divided men differently, women differently. There was no women in men group and vice versa. So like that, based on some variable, we will be making mutually exclusive group. One strata is totally exclusive to the other stratum. One stratum is totally different from the other stratum, and that is different from the other stratum. Okay, but within the stratum, within the group, all are having equal characteristics. Simple random samples are then drawn from each stratum. After making the ordered stratum, then simple random sampling will be applied. So after making a group of 6 women and 3 men, 4 men, simple random sampling is applied to select a particular woman from that stratum and particular men from that stratum of 4 men. So like that, stratified sampling is going to be applied, and this is how the stratified sampling looks. List of clients: Caucasians, African American, and Hispanic American. So based on some geographical area, the stratum are going to be made, and in this group all are Caucasians, in this all are African Americans, in this group all are Hispanic American group members. Okay, so we have different people coming here, and after this random samples of n by n size are going to be made out of this. So this is how the stratified sampling method, as a part of probability sampling method, will be used by researchers in order to do their research. So that is, population is divided on the basis of characteristic of interest in the population. Example, male and female may have different consumption patterns. Okay, for example, if you take consumption pattern, they have different consumption patterns. Based on that character also, you can group the people. Okay, has a smaller sampling error than simple random sample, since the source of variation is eliminated. It's very, very important. In this stratified sampling, source of variation is eliminated. That is, what we have selected is definitely going to represent that particular group, is definitely going to contribute for the research, because we have not selected the sample randomly. We have made the group based on these characteristics, and then we have taken one sample as a representative. So as it is mentioned, a smaller sampling error is also an advantage of stratified sampling. So it ensures representativeness when proportional sampling used. Yeah, very important thing is that as the ordered groups are made based on some criteria, each sample selected is definitely going to be representative of that particular group. So it ensures representativeness compared to the other sampling method. Next thing, direct proportional stratified sampling. The sample size in each stratum is proportional to the stratum size in the population. Even this can be done. Direct sample proportional stratified sampling can be done. Disproportional stratified sampling, the sample size in each stratum is not proportional to the stratum size in the population. So this kind of disproportional stratified sampling is used if some strata are too small, some strata are more important than others, some strata are more diversified than others. So depending on different criteria, whether the strata size is small or big, whether the strata members are important or not, whether the strata are members are diversified or not, based on these criteria, we will be using direct disproportional sampling, stratified sampling method as the sampling design. Next, we have the fourth type. First type was the simple random sampling, second type was systematic sampling, third type stratified sampling, and the fourth type of probability sampling design is cluster sampling. That is, clusters of population units are selected at random, and then all or some randomly chosen units in the selected clusters are studied. Here it is totally opposite to stratified sampling. In stratified sampling, the members in each stratum were having common characteristics, and the one stratum was totally mutually exclusive compared to the other stratum. But in clustering, in each group we have mutually exclusive members. We are going to group men, women in the same cluster. Then we are going to take the representative from. So what are the steps required for the cluster sampling? Population is divided into mutually exclusive and exhaustive subgroups. The entire population is divided into mutually exclusive, exhaustive subgroup, and they are called as the clusters. Ideally, each cluster adequately represents the population. Okay, in that cluster, if we take some samples, only that cluster members will be able to represent the entire population. Okay, suppose we were talking about the history students and math students, though those all students will be there in the single cluster. If you want to take representative from the math on behalf of maths, we can select the math samples from that cluster, or the students who study history, they can also be taken from that particular cluster. So that is, ideally the cluster adequately represents the population. A simple random sample of few cluster is selected. All or some randomly chosen units in the selected clusters are studied. Sometimes we study all the chosen units, or sometimes we study only randomly chosen units that are part of the cluster. So here it is showing dividing the population into clusters based on geographic boundaries and randomly done simple clusters and major units within the sampled clusters. So here it is indicating green color with north, and orange with north central, red with central, blue with south central, pink with the south. So like that the clusters are made, and each cluster is having mutually exclusive members. It's not like the clusters are having the homogeneous elements. All the elements in single cluster are heterogeneous. If we select randomly some members from that particular cluster, some samples from that particular cluster using simple random sampling technique, we will be able to get the desired feedback, desired input, because each member in the group is capable of representing the entire population. So that is the cluster sampling. Selecting a sampling design, when to use stratified sampling. So when it comes to application, when to use stratified, when to use the clustering, of course there are some set of rules and regulations. The first thing is when to use stratified sampling. If primary research objective is to compare groups, if at all your research is all about comparing the groups, comparing the communities, comparing a set of particular people based on some geographical area, based on some gender, something like that, then the stratified sampling is most suitable, most appropriate for the research. So using stratified sampling may reduce sampling errors. Just now we saw the use of stratified sampling leads to very minimal sampling error, because all the members or the samples that are selected in the stratified sampling are based on some basis, or based on some variable, based on some characteristics. Okay. So when to use the cluster sampling? If there are substantial fixed costs associated with each data collection based on the location, when there is a list of clusters but not if individual population members are available. So under such circumstances, we will be going for the cluster sampling. Okay. So this is how we covered the important 4 sampling methods under probability sampling. Okay. Now we will move on to the next type of sampling design procedure, which is having not equal chance of getting included in the sample nature, that is non-probability sampling. So under this, each sample used will not have equal chance of getting included in the study. Okay, it depends totally on the researcher. Researcher is the ultimate decision taker. He is the supreme authority who is going to select the sample based on his own observation, based on his own personal decision, based on his own convenience, based on his own interest. He is going to select the sample. There is no kth unit, there is no ordering, sorting kind of things. So totally it is the researcher's discretion as far as selecting the samples for the study. So under this we have different types of methods. Okay, before we move on to the methods, what is this non-probability sampling? It is a subjective procedure. It is not an objective procedure. It is a subjective procedure in which the probability of selection for some population units are 0 or unknown before drawing the sample. So before you draw the sample, there will be a lot of discussion, that is why, how and all that. Based on that, the researcher is going to take the decision. Information is obtained from a non-representative sample of the population. Maybe the sample selected is non-representative of the population. Under that condition also information is obtained, and sampling error cannot be computed. That is very big disadvantage of non-probability sampling. There is no provision for computation of the sampling error. Survey results cannot be projected. If you apply this, if you adopt this method of non-probability sampling, survey results cannot be projected to the population. Okay. So selecting sampling design from non-probability sampling are having some advantages, that it is cheaper and faster than probability. You can do the sampling faster, less expensive, reasonably representative if collected in a thorough manner. So it is only based on the researcher's skill and researcher's capability, the sampling is going to be done. Okay. So what are the different types of non-probability sampling? The first thing is convenience sampling. As the name itself suggests, that convenience sampling is convenience of the researcher. The researcher's convenience forms the basis for selecting a sample. That is, he will be selecting some samples like people in my classes, mall intercepts, people with some specific characteristics. Say, for example, people with bald hair, bald head will be selected by the researcher. Okay. So this kind of sampling is totally vague, and it is totally based on convenience of the researcher. It is left to the researcher to whom he is going to select for his research, and how he is going to take the information is left to the researcher. But that becomes a very vague kind of sampling method. The second type of sampling is judgment sampling. Okay, as the name itself suggests, a researcher exerts some effort in selecting a sample that seems to be most appropriate for the study. It's a judgmental sampling, that is it is his assumption, or it is his prediction, or it is his uh, visualization that this sample is definitely going to contribute, this sample is definitely going to be appropriate for my study. So based on this assumption, or based on this fact, the judgment is done by the researcher, and the selection is done by the researchers. The third type of non-probability sampling is snowball sampling. That is, as the name itself suggests, it is snowball. That is, selection of additional respondents is based on referral from the initial respondents. Okay, that is, sometimes you select some people, your friends, you select for some particular job, for some particular interview or interaction. Then you will ask in the process whom you can refer again for this particular kind of interaction. Then friends of friends can be referred by the initial respondent. That is, initial respondent will give some referrals. Based on that reference, you are going to sample, or you are going to select some more samples. Okay, this is selection of additional respondents based on referrals from the initial respondents. And this kind of snowball sampling is used to sample from low incidence or rare populations. So this is suitable for low incidence or rare populations. Okay, the next type of sampling is the quota sampling. So as we know that there are different quota available in every population selection, the population is divided into cells on the basis of some relevant control characteristics. The quota of sample units is established for each cell. Say for example, women quota, men quota. Okay, we have 50 women, 50 men. A convenience sample is drawn for each cell unit until the quota is met. So it is almost similar to the stratified sampling. The numbers are going to be fixed in the quota. We were discussing 6:4 ratio. Always you have to make, somehow you have to select 6 women and 4 men in stratified. Like that here also, the quota has to be fixed. The number has to be filled. Okay, so until we meet the quota. So based on this, we have some quota sampling, and the 4 methods of this non-probability sampling are not that accurate compared to probability sampling. Because of that, the possibility of making errors is high in non-probability compared to the probability, and the computation of the error is also difficult compared to probability sampling. So these are some differences between probability and non-probability. And now let us, after having studied the different methods, sampling design techniques under both the types, that is probability, non-probability, we will try to compare and contrast all these 4 methods collectively. Okay, so the differences between probability versus non-probability sampling, that is, non-probability sampling is less time consuming and less expensive, as the decision is taken totally whole and soul and solely by the researcher himself. The decision is faster and it is less expensive compared to probability. The probability of selecting one element over another is not known, and therefore the estimates cannot be projected to the population with any specified level of confidence. Quantitative generalization about population can only be done under probability sampling. So however, in practice, marketing researchers also apply statistics to study non-probability sampling. So in simple terms, non-probability simple sampling method is not that accurate compared to probability, and there are some quantitative generalizations and which are made in order to adopt the non-probability sampling. Okay, so what is this generalization? You can only generalize the population from which you sampled. Okay, say for example, U of L students, not college students, not Canadian population, Canadians not people everywhere. So based on some criteria, you are making some generalization and you are drawing some conclusions from the samples. Okay, so this is the example of generalization. Okay, so this is how the methods under probability, non-probability are selected, and we have different types under each method. Okay, the last topic in this unit, that is sampling design, is errors in the survey, random sampling errors and non-random sampling errors. These are the two types of errors. So what is this random error? The sample selected is not representative of the population due to chance. So, okay, you have selected by chance, you have selected a sampled a particular element, particular sample you have chosen, but it is not at all able to contribute, it is not at all able to provide you any input based on your study. It is not at all in a position to represent the entire population. It is not representative in nature. So under such cases, we come across this kind of error, that is random error. The level of it is controlled by sample size. So how to control this random error? We can control this random sampling error by sample size. So if you go for more sample size, probably the error can be less. The larger sample size leads to smaller sampling error. Yeah, in order to reduce the error, you have to go for larger sample size. So instead of taking feedback from 2 students, it is better to take feedback from 10 to 15 students. So in that case, the possibility of error or the quantity of error is going to be controlled. So population mean is represented as mu, and sample 1 is taken, sample mean of the sample is taken in order to compute the errors. So that is the simple random sampling error, and there is one more type of error that is possible in sampling designs, that is non-sampling errors. We will sometimes refer to this kind of error also as the systematic error. As the name itself says, it is a systematic error, and the level of it is not controlled by the sample size. Like that, in random size, you are able to control the particular random sampling error. If you increase the sample size, you were reducing the random sampling error, but here it is not at all possible to control the sample size, random sampling error, this kind of non-sampling error based on the sample size. There are two basic type of non-sampling errors, that is non-response error and response or data error. So these are the two types of non-sampling errors. What is this non-response error? A non-response error occurs when units selected as part of the sampling procedure do not respond in whole or in part. So when units selected for the study, for the research, when they fail to respond as a whole or in part, or only the selected samples, when they fail to respond, under such cases the researcher will not be able to get any desirable information, any desirable thing or expected thing. So under such circumstances, we come across this kind of error, that is non-respondent or non-response errors. If non-respondents are not different from those that did respond, there is no non-response error. Okay. So what is the other type of error under this non-sampling? That is the response error or the data error. Is any systematic bias that occurs during data collection, analysis or interpretation. This kind of error may occur during data collection, during analysis of the data, or during interpretation of the data. So in any of these three phases, this kind of error can occur. That this respondent error is basically lying, forgetting is an example for respondent error, and sometimes interviewer bias leads to this kind of error. Sometimes the interviewer only will bias, that is based on some influence and all, the interviewer will end up selecting the wrong sample for the study. Recording errors, poorly designed questionnaires, all these kinds will, all these methods of data collection or interaction will lead to the data error or the respondent error. So when the poor questionnaires are given, when you are expecting something, accordingly the strong questions have to be chalked out, and for strong questions, and the nature of the question should be very high, and should be selected properly. Otherwise you will not be able to get the desired information or the answers. So under such cases we will be coming across this kind of response or data error. Okay, so this is how the sampling methods discussion ends here. That is, we have studied the different types of sampling methods under the probability, non-probability, and we have studied the different types of errors. Please go through the video, log into Impartus, go through the video, and you can just work out some problems, go through some problems that are available in CR Kotari textbook. They have given some illustrations with respect to some numerical problem as far as these stratified sampling, systematic sampling methods are concerned. They are very simple problems. They have used some statistical parameters like standard deviation, mean, etc., and try to understand, solve the problems. And if you don't get the solution of that problem, they are solved problems. If you are not able to follow the procedure how the problem is solved, you are free to raise any questions, queries on the Impartus video. Okay, and I will be there immediately. I will respond you back with the answer or the solution. I will make a video of how that solution comes, and then I'll share it with you. Okay, thank you.